Is there a missing planet between Mars and Jupiter? A deep dive into NASA's new discoveries and the solar system's ancient secrets. The idea that our solar system once housed an additional planet between Mars and Jupiter is not new. This hypothesis, first proposed in the 18th century, is rooted in a curious mathematical pattern known as the Titius-Bode law. For centuries, astronomers and scientists have speculated about this so-called missing planet, and modern discoveries, combined with NASA's ongoing investigations, have reignited interest in one of the solar system's most enduring mysteries. Could there once have been a fully formed planet in the region now occupied by the asteroid belt? And if so, what became of it? The birth of the missing planet theory. Titius-Bode law. The seeds of this mystery were sown in the late 1700s when German astronomers Johann Daniel Titius and Johann Alert Bode formulated a simple but intriguing mathematical rule for the distances of planets from the Sun. Their rule predicted that there should be a celestial body orbiting the Sun at a distance between Mars and Jupiter. When they applied the rule, it closely matched the distances of the known planets from the Sun at the time, but there was a glaring omission. The space between Mars, $1.50, and Jupiter, $5.20, was empty. According to their calculations, a planet should exist at around 2.8 astronomical units, AU, roughly where the asteroid belt is located today. The hunt for the missing planet and the discovery of Ceres. Following the publication of the Titius-Bode law, astronomers launched an intensive search for the missing body. Their search bore fruit in 1801 when Italian astronomer Giuseppe Piazzi discovered Ceres, a round object with a diameter of about 940 kilometers, located exactly where the theory had predicted. At first, astronomers believed they had found the missing planet. But as more objects were discovered in the same region, such as Pallas, Juno, and Vesta, Ceres was no longer considered a planet. Instead, scientists realized they had stumbled upon a belt of millions of rocky bodies, what we now know as the asteroid belt. NASA's new evidence and the role of Ceres. Ceres remains a unique object. In 2006, it was reclassified as a dwarf planet, sharing the status with Pluto, Eris, and a few others. Yet Ceres is unique in one major way. It is the only dwarf planet located in the inner solar system, inside the orbit of Neptune. NASA's Dawn spacecraft, which orbited Ceres from 2015 to 2018, made some groundbreaking discoveries. It found evidence of water ice, organic compounds, and possibly even a subsurface ocean. These findings suggest that Ceres may have been geologically active in the past. In other words, it might be more than just a lifeless rock. It could be a remnant of a much larger, dynamic world. Asteroid belt. Debris field or unfinished planet. So, what exactly is the asteroid belt? There are two main competing theories. It is the remains of a planet that was destroyed. It is the leftover building material of a planet that never formed. Theory 1. The asteroid belt as planetary debris. This theory suggests that a planet once existed between Mars and Jupiter but was destroyed, possibly by a catastrophic collision with another planetary body. Gravitational disruptions caused by the immense pull of Jupiter. Even more exotic scenarios, like an internal explosion triggered by accumulated dark matter, a fringe but fascinating theory. Computer simulations show that early in the solar system's history, chaotic collisions were common. A protoplanet in that region could have collided with another massive object, shattering it into countless fragments that now form the asteroid belt. However, there's a major problem. The total mass of the asteroid belt today is less than 1/1000th of Earth's mass. A full-fledged planet would have had much more mass than this. So, if there was a planet, where did the rest of its material go? Some scientists believe the mass was either pulled into the Sun, thrown out of the solar system, broken down into dust over billions of years. Still, the chemical diversity of asteroids in the belt complicates the idea of a single parent body. Many have different compositions, some rocky, some metallic, some icy, suggesting they may have formed in different parts of the solar system. Theory 2. A planet that never formed. Another, Perhaps more widely accepted theory today is that the region between Mars and Jupiter had the potential to form a planet, but never did.
Why?
The culprit is likely Jupiter. Jupiter's massive gravitational field exerts such a strong influence on the asteroid belt that it may have continuously disrupted the process of planetary accretion, the gradual coming together of smaller bodies to form a planet. In essence, Jupiter acted as a cosmic gatekeeper, preventing material in the belt from merging into a single large object. This idea is supported by computer models showing how Jupiter's gravity would stir up the orbits of nearby planetesimals, making collisions too violent for coalescence into a stable planet. Dark matter, rogue planets, and cosmic collisions. More speculative theories exist too. Some astrophysicists have posited that a concentration of dark matter at a planet's core could eventually destabilize it, leading to internal collapse and explosion. While there's no direct evidence for this occurring in the asteroid belt, it illustrates just how dynamic and mysterious planetary formation can be. Others suggest that rogue planets, large bodies ejected from their original systems, may have swept through our early solar system, disrupting orbital paths and shattering a planet into debris. One such rogue planet may have caused the tilt of Uranus, or even helped eject Neptune to the outer edge of the solar system. Ceres, the clue to the past. Amid these grand cosmic dramas, Ceres stands as a quiet survivor. Its round shape, internal structure, and traces of water and organics make it a fascinating object of study. Some scientists now believe that Ceres may be the only remaining fragment of a once larger body that came close to becoming a full planet but was stopped mid-formation. Ceres may even have retained an ancient subsurface ocean, shielded from the cold vacuum of space. If true, it raises tantalizing questions about habitability and the potential for extraterrestrial microbial life in places we've never thought to look. What does the future hold? NASA and other space agencies continue to explore the asteroid belt. Future missions could investigate whether some of the larger asteroids like Vesta and Pallas show signs of differentiation, layering into core, mantle, and crust that would indicate they were once part of a larger protoplanet. At the same time, new astronomical surveys are helping to refine our models of solar system formation, looking for subtle gravitational tugs and patterns that might hint at hidden objects or past cosmic events that shaped the inner planets. Conclusion: a planet lost to time? The question remains open. Was there once a planet between Mars and Jupiter? Perhaps. It's equally possible that a planet was never fully formed, thwarted by the might of Jupiter, or that a massive planet was torn apart in the early chaos of the solar system. Either way, the asteroid belt holds a cosmic memory, a record of what might have been. Ceres, with its water, shape, and mysterious features, may be the key to unlocking this ancient chapter in the story of our solar system.